Hello, and thank you for joining me as we wrap up writing ionic formulas. So today, our objective is to be able to write and name ionic compounds. We're also going to be able to differentiate between hydrates and anhydrous compounds, which are just a specific version. So here we go. To start, let's review really quick. Atoms that lose electrons and to form ionic bonds are called cations. When they lose electrons, they have a positive charge. When they gain electrons, they become anions and they have a negative charge. So when we write our name, it's really important to know the difference between these two because you must write the cation first. When you write the name, you always write the cation first, and you're written just as the element name. When you write the anion afterwards, you're going to change the ending to IDE. Okay, so this is how it's going to look. Our example is NaCl. So Na is sodium, so my cation is sodium. My anion, Cl, is chlorine. Now to write this correctly, we change the ending to IDE. So when I change that, it's going to be CHLORIDE. Then I'm going to put the name together. This is going to be sodium chloride. So this is how we're going to write ionic compounds. This is all we have to do. Write the cation name, anion, change the ending to "ide." Now there may be one little piece extra, but that's close to all we have to do. So here we go. First one, Li and F. Li stands for lithium. F stands for fluorine. Change the ending to IDE. This becomes lithium fluoride. KCl. K is potassium. Cl is chlorine. Change the ending to IDE. This becomes potassium chloride. Okay? Now, this one. I have two here. When it comes to ionic compounds, this does not matter. This is done to make the compound neutral because magnesium has a charge of +2. Chlorine has a charge of -1. So I had to bring the 2 over to here and the 1 went over there. That's why we got MgCl2. Naming wise, we keep it the same. So it's still magnesium. Whoops. Pen. Still magnesium. Still chlorine. Going to form magnesium chloride. Try these last two on your own. Pause the video. When you hit play, I'm going to give you the answers on the next slide. Okay, so pause this, try those, hit play, and here are your answers. So the last two is lithium sulfide, and this one is copper-1 fluoride, because copper is one of those transition metals that's got multiple valence states. So copper needs the copper-1. Some more practice. So on this one, we're going to get some practice with those transition metals. So Cu and O. Cu stands for copper. O stands for oxygen. Now, it's really important we think through copper here, because copper is a transition metal, so we have to change oxygen to oxide, so it's going to end in oxide. With copper being a transition metal, I need to figure out what the charge is on this copper. So what I'm going to do is I'm going to uncross and undrop my charges. So right now there's a 1 and a 1, but you got to be careful because oxygen always has a charge of -2. So this charge up here is going to be -2, which means that in order for it to be reduced to 1, this one had to be a +2. And so then when I cross and drop, I get Cu2O2 becomes CuO. So in this case, I have copper, and the Roman numeral signifies my charge, which we said was 2. So this is copper-2 oxide is going to be my formula here. Okay, try this next one. Uncross, undrop. use the Roman numerals, and write your answer out. Pause the video. Try these next 3. Be careful down here. That has a special name, this has a special name, and this has a special name. Use the name you know for this compound, not "ide." So these are polyatomics, leave them as polyatomics. But try these out. I'll actually do this one for you. This is lithium, and if you look at your sheet, you know CO3 is carbonate. Charges don't matter, just names. Lithium and carbonate. Perfect. Okay, so try this one. Or try Fe2O3, KOH, and NH4Cl. When you're done with those, hit play, and I'll give you the answers. So here are your answers. So if you uncross and undrop these, you get a 3 over here by the irons. This is iron 3 oxide. KOH is potassium hydroxide. NH4Cl is ammonium chloride. All right, last little bit. We have substances called hydrates. When you think of the word hydrate, what do you think of? Most of the time, people think of water. So a hydrate is an ionic compound with water attached. An example would be copper 2 sulfate pentahydrate. The formula for this, if I have copper 2 sulfate, I'm going to cross and drop. And so I'm going to get CuSO4, Cu2SO42, which becomes CuSO4, because these can both be divided by 2 to make 1s. Now, this pentahydrate, when you write the formula for a hydrate, you put a circle, essentially a multiplication sign, and you put penta means 5, and hydrate refers to water. This would be your formula for copper 2 sulfate pentahydrate. If it's anhydrous, that means without water. So, for example, anhydrous ammonia is just NH3. Ammonia hydrate, we added a water to it, so this first water joined the NH4, which is left with an OH. So water got split here, but this is the same thing as this, written differently. Okay? Really quick, I would like you to answer, what's the formula for gold 1 oxide? So pause this video and make sure you answer these. What is the name of HgOH2? And what is a hydrate? Pause the video, answer those 3 questions, hit play, and we'll wrap things up. All right, here's some practice. I would like you to both write the formula and name the compound here. So the first one, we have Be and Cl. So Be is positive 2, Cl is negative 1. I'm going to cross and I'm going to drop. I get Be1Cl2, which is BeCl2. To name this, Be is beryllium. And Cl is chlorine. Change the ending, so it's going to be beryllium chloride. I'll let you work through the rest of these. Give me a formula and a name, and I will have the answers on the next slide. So pause the video, work through those until you're comfortable, and then hit play. Here are your answers, so go ahead and pause this video. Check your answers here, make sure you match. If we don't, come see me. Let's figure it out. But hopefully things are going well. And the last little bit, I want you to write the formula for these compounds. So write the formula here for these guys. They've given you the name, write the formula, pause the video, and I have the answers on the next slide. So here are your answers to check your work on the previous one on these, and then we'll wrap things up for the day. So your last couple questions. Which elements need Roman numerals when you write the name? And then I want to know, how do you write ionic formulas and how do you write the name? What are the steps for writing the formulas? What are the steps for writing the name? Thank you for working with me through this unit. I'm excited to help you develop your understanding of chemistry, and we can learn together a little bit. And we will come to a close with the next lesson here on covalent bonding. But thank you for your time, effort, and energy today, and I hope that you enjoy the rest of your day. I will see you next time, and have a good one.